Hello, everyone. Now we're going to talk about the Kruskall-Wallace test. The Kruskall-Wallace test is used to compare two or more groups. Although typically we don't use it for two because we have other tests that can compare just two groups. So usually it's three or more. And the way that this works is similar to other non-parametric tests, and that we're going to take all of our observations, squish them all together, and then rank them, temporarily ignoring what groups they came from. And then we'll separate it back into their groups once they've been ranked, and then we sum in each of the groups. If we have observations that are the same value, that are tied, then they get the average rank. So the Kruskall-Wallace test is the non-parametric counterpart to one-factor ANOVA, or one-way ANOVA, when the assumption of normality is not met. So typically we have smallish samples with outliers. That's when we're going to want to use the Kruskall-Wallace test. For the null hypothesis, we could talk about the centers for all the groups being the same, or the location of the centers are all the same. Sometimes you'll even see it phrased as the median of all the groups are the same. Versus HA, at least one of the centers is different. The assumptions for the Kruskall-Wallace test, you'll notice, does not include normality, because that's an assumption for one-way ANOVA. We do this test when we don't have the assumption of normality met, but we still have to have the independence assumption, meaning that we need to either have random selection, so we've randomly selected our groups from K population. So if we had 3 groups, we're randomly selecting from those 3 populations, or random allocation, so we're randomly determining who gets each of our treatments. So maybe 3 different treatments. So maybe they see 3 different commercials, and we randomly determine that. And our groups need to be independent. So we need to have only one measurement from each individual, and each individual can only appear in one group. If we have that, then we can go ahead and compute our test statistic. Our test statistic is H, so H equals 12 over cap N times cap N plus 1. The cap N here is our total group sizes. So if we take our sample sizes for each of our groups and add them all together, that gives us cap N, times the sum of TI squared. So TI is the rank sum for each of the groups. So remember, we ranked everything, we squished it all together, we ranked everything, and then we pulled it back into the group, and we found those ranks. So if we sum over the ranks of the groups, that gives us TI. We divide it by NI, the sum for the sample, minus 3 times N plus 1. Once we have that, then we can compute our p-value. Our p-value we can get from the chi-square distribution, which we can see here is skewed right. And we're going to shade to the right. So the bigger that test statistic is, the more evidence we have for HA. And the degrees of freedom is K minus 1, where K is our number of groups. So in this case, our degrees of freedom is 4 minus 1, so we must have 5 groups, or K equals 5. So this talks about the Kruskall-Wallace test, which is used to compare 2 or more groups.